Hello, and welcome once again to Backer Breaks It Down, where we still are focusing on trig functions of any angle. Okay, but I want to talk about the signs of trig functions. I've said, watch your signs. And so that really just involves paying attention to the quadrant you're in, because if you're in quadrant 1, both x and y are positive. In quadrant 2, only y is positive. In quadrant 3, both are negative, and in quadrant 4, x is positive. So we've talked about that, but let's talk about the actual trig functions themselves. Okay. So I was a trig student. They taught us the acronym all students take calculus, right? And so that stands for ASTC. Okay. And so going back to this diagram here, that's where the A, S, T, and C we're representing. So all students take calculus. All is for all. S is for sine, T is for tangent, C is for cosine. Okay, so basically what this little acronym or mnemonic is telling us is what's positive. Okay, and so in quadrant 1, all trig functions are positive. In quadrant 2, sine is positive, therefore its reciprocal function, cosecant, is also positive. In quadrant 3, tangent and cotangent are positive. And in quadrant 4, cosine and secant are positive. So the next example, okay, gives us a trig function. So it says tangent is negative 2 root 5 over 5. And sine of theta is greater than 0. And we have to use that information, and we have to be like, well, what quadrant is that? And so these little diagrams here kind of like our way of us kind of maybe mapping out what we're thinking about the constraints and what the possibilities are. So in this example here, it says sine is less than 0 and cosine is greater than 0. So what we want to do is we want to think about, okay, where is sine less than 0? Okay, so where is it negative? Well, sine is negative in quadrants 3 and 4. So notice they put check marks there. This says cosine is greater than 0, so cosine is positive. Cosine is positive in quadrants 1 and 4. Okay, so then they put these two diagrams together. All right, and so where is sine negative and cosine positive? Well, sine is negative and cosine is positive in quadrant 4. So that's where I would draw my reference triangle. Here's another example. They say cosecant is greater than 0. All right, well, everything is positive in quadrant 1. Cosecant, according to our table and diagram up here, is positive in quadrant 2. Here it says cotangent is negative square root of 3 over 3. So we're like, where's cotangent negative? Okay, cotangent is negative in quadrants 2 and 4. So where's the overlap? Quadrant 2. So quadrant 2 is where cosecant is positive and cotangent is negative. Right? So going back to this example in our notes, we are given that tangent is negative 2 root 5 over 5. So where is tangent negative? Tangent would be negative in quadrant 2 and in quadrant 4. Okay. The other constraint that they give us is that sine is positive. Well, where is sine positive? Well, everything's positive in quadrant 1. Sine is positive in quadrant 2. So according to our little analysis here, we want to draw a reference triangle in quadrant 2. Okay, now we want to label the sides with what we're given. So what exactly were we given? Remember, we were given that tangent was negative 2 root 5 over 5. And as you know, tangent is the opposite over the adjacent. So opposite, adjacent. Okay, so the opposite is 2 root 5. The adjacent is 5. So what about that negative because it was negative 2 root 5 over 5. So where does the negative go? Well, here in quadrant 2, the x values are negative. So the negative goes with the x value. So notice that we're still missing r, the hypotenuse. So you know what that means. Pythagorean theorem. So I did the math and I came up with r is 3 root 5. So once you have all three sides of your reference triangle, pause, check your signs, S-I-G and S. Okay. And then you can go about finding your ratios. Okay. So we all know sine is opposite over hypotenuse. So we're going to have 2 root 5 over 3 root 5. And if you're thinking, would those root 5s cancel out? I would be like, yeah, they would, because you've got one on top and one on the bottom. So sine is simply 2 over 3. Flip to find its recip, cosecant, it's 3 over 2. So now we're ready to find cosine. As we know, cosine is the adjacent over the hypotenuse. So the adjacent is negative 5. The hypotenuse is 3 root 5. Gonna have to simplify that. But before I go simplifying that, flip it. Flip to find the recip. Secant would be 3 root 5 over negative 5. So then go back to cosine and clean that up. To clean it up, we're simply going to multiply the top and the bottom by the square root of 5. And so we're going to get negative 5 root 5 on top. On the bottom, we're going to have 3 times 5, which is 15. And how lovely. That can be simplified one more time. The negative 5 on top and the 15 on the bottom can be reduced to negative 1 on top and 3 on the bottom. So like the final answer here for cosine is going to be, and I'm going to have to like write it over here, is going to be negative square root of 5 over 3. Because yeah. And then cotangent. Well, they gave us tangent. Flip it to find the recip. We're going to get negative 5 over 2 root 5. And yeah, we do need to rationalize that. So we're going to multiply the top and the bottom by the square root of 5. So then on top, we get negative 5 root 5. On the bottom, we have 2 times 5 is 10. And look at that. Once again, we can simplify the outside fraction, giving us negative 1 root 5, or simply negative square root of 5 over 2. Okay. So basically, it's what we've been doing. Okay. They're giving us basically two sides of our triangle. We're finding the third side using Pythagorean theorem. We have to figure out where our reference triangle is located. Okay. And so here they were kind of vague about it. But using the constraints that tangent is negative, sine is positive, we determined quadrant 2 is where both of those things happen. And that is how Backer breaks it down.